Good day to everybody. Thank you for attending this RSA webinar today. My name is Artur Kosakowski and I will be running today's presentation along with my colleague Rafał Gawenda. The topic of this webinar is troubleshooting meshing issues. Let me remind about the concept of the RSA webinars. We will focus on one or several topics in order to discuss issues frequently submitted to the support team. We will begin with the general introduction of selected features of the program and develop these subjects further based on the feedback we will receive from you after each of the presentations. Please mind that these webinars are not supposed to be training sessions. In this webinar, we will discuss the most common causes for meshing issues, show how to find them, and demonstrate available tools and techniques for both obtaining coherent meshes and meshing panels which have issues with mesh generation. For the next webinar, we'll focus on the steel design module of a robot. From our experience, the most common cause for issues with meshing is by far lack of accuracy in the definition of the geometry of a model. Typical errors include gaps between panels, partially overlapped panels, parts defined not exactly along edges of panels. It also often happens that contours of panels have additional or inaccurately defined characteristic points which have negative influence on meshing. The latter is most of the times caused by snapping to other objects than intended, so be careful where you click while defining panels. These are the symptoms that should alert you for potential meshing problems. Thicker edges may indicate two parallel lines instead of a common edge. Strange-looking color of interior suggests that a panel or an opening is not in the right plane. Next 2 points are the consequences of having an inaccurate model. They indicate that the robot tried to generate correct meshes by changing the order of panels meshing. When this fails, you will often see the effect described in the last 4 points on the list displayed on this slide. The best way of checking both the coherence and the correctness of generated meshes is to launch model generation and verification. You may want to perform these actions before running calculations to verify if using results for the model as it was defined makes sense. This allows you to save time as you don't wait for the calculation process to finish when you already know that the results may be incorrect. In addition, you may check the quality of meshes and decide if they are acceptable before moving to the design stage. This last option was covered during our previous webinar, which I strongly encourage you to watch in case you haven't done it yet. After detecting and checking the range of the meshing issues in your model, you need to decide what correction options are the best to be used for a particular situation. For models with large number of meshing issues caused by lack of precision of the geometry detected in many locations of a structure, I would suggest to start with general correction tools first. This is intended for solving most of them at the same time. Then for still remaining issues, you can gradually limit the range of modifications to selected planes, panels, or just few nodes only. I'll show how this technique works on a couple of examples. Let me start with the global correction options first. As you can see, I've got a model where there are several locations that needs attention, and the best option to deal with all of them at the same time is to use geometry adjustment to structural axis. Okay, I will try to switch to my model now. Okay, the building that you saw previously. And first, I will run model generation and verification as I suggested. This is the first step to start with. So we have the generation of the meshes for the entire model based on the parameters assigned to the panels, and this is followed by the verification of the correctness of the model. Okay, so you can see we have two options here. And when you click on the error or warning, you will see the selection of the objects this error or warning is linked to. Let me open that in a new window, and you will see that first of all, you have this symptom that I mentioned, that we have a lot of nodes, concentration of nodes, and then you can see, maybe I switch off the display of the meshes, that we have actually overlapped panels, okay? So this is the first issue in this model, and if we click on the error, we have the location of the places where mesh is incoherent. Because you can see that there are many of them in different locations, so that's why I'm going to use this general correction tool. So I will first delete the meshes. And then I will go to the detailed correction option. I will select adjust to structural axis, and of course I will set the precision that matches the inaccuracy of the model. Then the software will automatically adjust the geometry of walls and slabs to the structural axis, and if we run meshing again, there should be no issues with meshing any longer. So this is the way to deal with problems that you have in many locations in the model. Okay, so let's go back to the presentation. And sometimes the required correction is needed only for a part of a model. For example, walls, floors, or openings defined in a particular plane. In such case, you can use the detailed correction option in the adjust to the indicated plane mode. Let me show this option on an example which has incorrectly defined wall opening. In addition, I will use this model to show what influence on meshing a wrong snapping during panel's contour definition has got, and demonstrate the way to correct such situation by moving the characteristic points of a panel's contour to the right location. Okay, so let me load another model. Okay, again, let's start with the generation of meshes and the verification of the correctness of the model. Okay, so we have two issues here. First of all, you can see that we have elements generated inside the opening, and the other problem is indicated in the warning that one of the panel is not has got no mesh generated, and the issue is here, as you can see, the inaccuracy in the definition of the contour. So let me start with this issue first. I will switch the characteristic points of the contour, and I will move the contour graphically so that it is in the correct position. Okay, when you click on the contour and click again, you can drag it, and the same, okay, I've got these characteristic points that I do not need to have, and I move it to the same location. So this is the first issue, and the second issue is with the opening. So maybe, okay, I will delete the mesh first so that you can see the effect of the operation I'm going to perform. I go to Edit, Detailed Correct again. This time I want to snap to the plane, so I will indicate the wall corners, okay, and this is the correction done for the opening. So if I mesh the model again and run verification, this time I should have no issues with mesh generation. Okay, as you can see, there is the opening and there is the, I made a mistake. Okay, let me recover from that. I mentioned previously that it is important to match the correction option with the distance of the error. And okay, you can see the distance here is like 1 centimeter or maybe slightly more. And okay, running the detailed correction option, I should indicate the plane as I did previously, but I should also mark, enter the right precision. Okay, in this time, okay, it is 2 centimeters, slightly more than the error that I made in the geometry. Okay, so let's mesh it again. Yep, that was not intended, but actually that may be a good situation that it happened. Okay, so let me go back to the presentation. The correction of the excessive characteristic points of a contour or these defined with wrong coordinates can be also done in the panel's properties dialog. Let me show this on another example, and I will switch back to robot. I will load the single panel model. Okay, you can see there are two characteristic points next to each other. I will mesh this model to show the influence this has got on the meshing, and if I remove the mesh, I can go to the properties of the panel, and in the geometry part I can see the positions, the coordinates of the characteristic points. I will select the one that I don't need, which is excessive. I will remove it, modify the panel, and now if I run meshing again, you can see that the mesh looks much better than previously. Okay, let me go back to the presentation, and as I already mentioned, the generation of meshes is strongly influenced by objects defined at edges and inside panels. And such objects may prevent correct mesh generation, especially in a situation when selected meshing parameters doesn't match with these objects. In such case, you may try to change the type of meshing algorithm or mesh density. Let me show that on another example. So I will go back to the program. I will load the model. And again, mesh generation followed by the verification. Okay, there is incoherent mesh reported. And if we switch display of nodes, you can see that I've got two excessive nodes generated here with elements. So what I'm going to do, I'm going to check what parameters I assigned to the selected panels, and meshing parameters include regular mesh. I will switch off regular mesh, and I will just generate the model again. And this time, okay, the different algorithm handled the situation in the better way, and there is no excessive number of elements or nodes in this location. Okay, and let me go back to my presentation again. In some situations, for example, imagine a large and very complex model where you have all the meshes generated correctly for almost all locations, but just tiny issues. In such situation, you may actually decide against any corrections of the panel's geometry. The chance is that you may unintentionally make things worse by changing the geometry in the locations that you do not want to do so. In fact, it may be just enough to move and merge a couple of nodes instead. Let me show how this is done on the same model that I've just used. This time, imagine that it is a small part of a huge skyscraper, for example, opened in a U window. So if I go back to robot, I will just reload the example. And for the original settings of meshing parameters, I will run the generation of the meshes again, and we have this incoherent mesh on edges error. I will switch on the display of nodes, and this time, instead of changing the meshing parameters, I will open the translation dialog. I will select the nodes that I want to get rid of, and I will move them to the corner one, and then I will select all three nodes and I will just merge them. What is important is to remember that you should actually freeze such modified meshes. Okay, so when you run model generation again, these meshes are not reset to the original settings. And as you can see, there is no incoherent mesh reported. I mean, to illustrate what I mean, if I unfreeze these meshes and I run the model generation again, you will be again, that will be this original mesh restored with wrongly defined elements. So mind to freeze the meshes that you corrected. Okay. The most likely cause for incoherent meshes along arches is that they were defined in different ways. They should have the same center as well as origin and endpoints, and they should have the same number of divisions. Let me explain what it means on the next example. So when I open the model, you can see that we have a part of a tank with walls and part of the bottom plate. And if we run a verification, you can see that we have incoherent mesh on the edges. Well, let me first show how these walls were defined. If we select the panel and we go to its properties, we can see that in the parameters, the arc was defined like with fixed number of divisions, 32. If I go to the bottom panel and I check the properties of the bottom panel, you can see that this arc has been defined in a different way. It was like defined without this fixed number of divisions. So I'm going to set the same number of divisions, and I will modify this object, and then I will first delete the meshes and then run the model generation again, and you can see now we have a perfect match for both objects. All right, so there is one important thing that you should remember. Mind that intersections of panels are not automatically detected. So in the situation as shown on the slide, you should either add a line at the intersection or just replace the vertical panel with two smaller ones. And this latter approach is recommended in situations when you want to work with the results for stories, or when you want to access or check the results in the reduced results for panels table. Another solution for issues with meshing may be reversing order of meshing. This may help in many situations, and this is actually what the iterative adjustment of meshing does. But when you run this process manually with some additional adjustment of mesh parameters, this option may be more effective as you fully control the order of meshing. If everything you tried failed, you may copy the panel you have problem to generate mesh for away from the model, mesh it separately, and finally replace the original panel with the one that you meshed outside the model. And for this action, the last step is to manually move and merge nodes created at the edges of the moved panel with ones from neighboring panels existing at the same common edges. And the way to do so we just covered during this presentation. And finally, I mean, sometimes the issue with meshing is very simple. You just make a mistake in assigning the panel calculation model. For example, you select a curtain wall where you have no finite elements to be defined. So before you start exploring other options, make this simple check first. And as I mentioned, this is something that you should keep in mind because if you forget to freeze the meshes that you manually corrected, they will be regenerated and you will have to make all this work from the very beginning again. And let me finish this presentation with a couple of useful tips. Again, I would like to encourage those of you who haven't watched our first webinar to look at it at YouTube and learn how to set the correct meshing parameters to avoid any meshing issues in the first place. Seizing the opportunity, I'd like to introduce Autodesk network site where you can find useful articles on the topics covered during this webinar as well as on many others. And I think that now I would like to ask you to post the questions on the GoToMeeting questions tab. And I do apologize, but we may not be able to answer all of them during this webinar. If some will not be answered, please post them on the robot forum after the presentation. I will try to address them later on.
So Artur, we have a few questions that were already answered by
Yes.
Francois and Rafael, so thank you for doing that, guys. And then we have some coming in. So one here, you can let me know if this applies or not. When I have a pile cap consisting of a plate connected to piles by single nodes,
Yes.
what is the best way for meshing to get a realistic sectional forces to design the plate rather than having very high concentrated results on the connecting nodes?
Actually, I mean, this part was covered during our first webinar, and if you watch it, you can see that that was the option of the reduction results over the support used. We used actually Kang meshing to have the concentration, smaller elements generated around these points of interest. And after that, we switch on this reduction option, and that I think that's the answer for your question. I mean, you may also try to create rigid links from the common nodes or bar elements pile. That's my assumption how you model it, and the panel, and simply create sort of the rigid surface to reduce the peaks directly over the supports.
Great. Okay, so let's see, a few more coming in. When one meshes a panel again, why robot does not delete the old mesh?
It does.
Okay.
It does. If you, I mean, like, all right. If okay, we have two situations here. One is such that you have the mesh frozen, and then the mesh is generated, I mean, erased and generated again only when you use local meshing for this panel. Or when the mesh is not frozen, then it is done either when you run local meshing or where you run model generation, which includes the generation of the meshes from unfrozen panels in the entire structure. The reason I deleted the meshes during the presentation is only to show that in the clear way that, I mean, you can see that actually the mesh is deleted and generated again. Running that directly, it is like replacing the old mesh with the new one, and you may just skip the part that actually the mesh was first deleted. So you do not have to delete the mesh unless you have a frozen panel and you want to do this. Now,
Okay.
you can see, I mean, like if I select this panel and maybe I will change the parameters. Let me see. Element size, maybe. Okay, and if I run, that's the extruded panel, so maybe that's not a good example, but let me load one of these other models. Okay, for example, this one. Okay, so we will run mesh generation, okay, and then, for example, we set the different parameters like 0.5 meter meshing, and we run it again. Yep, so it is like the mesh is deleted and then generated again. You do not have to manually delete the meshes.
Okay, great. All right, so the next question, can I link a panel geometry to be dependent on the node geometry?
I'm not sure whether I understand this question correctly, but if you have some nodes in the model, you may snap to them defining the panel, and I'm not sure whether that's the answer for the question, but you can also use the detailed correct option to move the nodes to, I mean, the panel to the right location.
Okay, all right, let's see if that answers that. The next one, do you have some recommendations for analytical models in Revit? A lot of problems you showed are caused by analytical model issues.
Yeah, I think that the first option that I covered, the adjustment to structural axis, is the one to start with. I mean, my assumption is that you have incorrect analytical model in Revit, which causes issues with meshes in robot. So first I would just correct this analytical model using this additional this detailed correction option to structural axis. Otherwise, I would define the structural axis at the characteristic points of the model, like along the walls, at the level of the slabs, and then I would correct that. That's the first model that we covered during the presentation. I mean, then if you send back, if you update Revit model, you will update analytical model, correct it in robots. So there should be no further issues with that.
Okay, great. And actually what I'll do as well, I know we had the link on the slide, and there'll be an email following the presentation that does also give you the link to the YouTube channel, but I will put the link to the previous webinars as well in the chat in case you want to take a look at that. All right, so let's see the next question. Let me just resort my screen. Are we able to do a RC section analysis in robot? This may be a less relative to the subject question.
No,
so
it is actually. Yeah. Okay. That's again a nice question to hear, because I mean I mentioned that the next webinar is planned to. In the next webinar, we are going to cover the assumption of this workflow in the steel design module, but the next two are going to be focused on the workflow in the concrete design modules. So let's save this question for the next time.
All right, stay tuned. Exciting things to come. Okay, so let's see. All right, so it looks like we don't have any new questions just yet. We'll give it a minute. There were some questions that came up that were maybe a little bit off topic that Francois and Guillaume and Rafal had answered. Since we have a little time, I can maybe cover some of those in case you have the same questions on your mind. So let's see. Sometimes I verify that model and get no mesh problems, and then I try to run calculations, which then brings up incoherencies. And the response was, after playing with meshing or in between, you can run correction to merge generated nodes on edges, or run model generation before running verification.
Yeah, I mean, maybe this, I mean, if I may add something, like, okay, that may happen in the situation when you use local mesh generation. And if you do that for two neighboring panels, it may happen that at the common edge you have two overlapping nodes, each of them created during the generation of the meshes for each of the panels respectively. And it is at the stage of the model generation that these two nodes are actually merged. Or so maybe that's the reason that if that model generation was not performed, you actually have two separate nodes and incoherent mesh reported. But
okay. Great. All right. So there's a new question that came in. What is a proper way to cut holes in panels? We have opening type and we can do it with contour. I'm never sure what to choose.
Well, the one that it is easier to define in a particular situation, like the opening is usually when you have the architectural drawing and you have the coordinates which are like the size, I mean the reference from the, let's say, bottom corner of the wall to the one of the corners of the opening, and you know the size of the opening. And for example, if you have a slab, it may be easier for you to actually draw the contour of the opening. So it really depends which one is easier for you to define. That there is no difference for the final result. I mean, simply the decision is which one is easier to enter in a given situation.
Okay, great. Let's see, that was that one. All right, so we have the proper way to cut holes. Oh, there's a question about future webinar topics. Where can I find them? We do have a link to a link that goes to all of the series, and that is going to be updated. So I think we had done some direct invitations, but we will be setting up that homepage. I'll paste the link in the chat. Look for that as well. We do send a follow-up email after this to those registered as well as those who attended, and we can include the sign up as well there. So again, these are a little bit new, so we're still setting everything up, but we want you to attend, so we'll definitely make sure that you're able to sign up. All right, so lots of questions starting to come in now. Again, I'll read these, Artur. If there's one that makes more sense to do offline, let me know. If I have a model, if I have a model that has been meshed and I later apply a point load on that panel, which is not over a node, will the analysis pick this up after I rerun?
Okay, so if you define the node and in which you want to enter this point load and you remesh the panel, it will be recognized. But if, for example, you have a situation that you do not want to mesh your model again, you may actually select this option, which is like force in point, where you only give the coordinates of the location of the force, and this force will be distributed to the panel despite the fact that the mesh is not exactly generated, but that any node of a mesh is not generated in the location of the forces. So either option is available. So if you define a node and then you apply the force in the node, I mean using this option, then you need to remesh the panel and the mesh will adapt to the newly defined node. Or otherwise, for example, you freeze the panel and you just apply the load in this way, like a force in point rather than force in a node.
Great. So continuing on, this might be a follow-up to a question we had earlier, and we may have to ask Mohammed to clarify, but let me know if you recall, Artur. So assign support to be done before or after mesh freeze, does it matter?
No, sorry, say it again.
Assign support to be done before or after mesh freeze, does it matter?
Right. If you define a support as a linear support to the edge of the panel, then this support definition will be transferred to any node generated along this panel edge. If you first mesh the panel, then you will have to select the nodes and apply the supports to this selection. And this has got this shortcoming that when you redefine the mesh, you will need to do it again. So select the newly generated nodes and apply the supports. So therefore, if you want to indicate the entire edge of the panel is supported, it is recommended to apply linear support to this edge. And then you just do not have to think about this definition again.
Okay. All right. So for spring supports, is it better to do it before?
The same answer.
Okay.
The only thing is like when you define a support and you define the linear support and you go to the elastic, do not mark this checkbox. So then the elasticity will be automatically recalculated for each of the nodes generated along the panel of the edge, along the edge of the panel, depending on the distance between the neighboring nodes. If you mark this checkbox, then you will assign identical support to every node or generated along this line, regardless of the distance between the nodes. So make sure that it is switched off. I can hardly think of any situation that you need to mark this checkbox. And it is much better because, I mean, if you would like to assign this support manually to nodes, then you would have to make sure that the distance among these nodes is the same, so that you have the exact value of elasticity for each of the support. Okay.
All right, so we had some questions too about where the chat window is or how it's visible. It's in the GoToMeeting panel. Unfortunately, we can't have the panel going and share it at the same time on the screen. However, the GoToMeeting panel should have a questions chat. It might say questions/chat window.
I don't know.
And you can type your questions there. Oh, go ahead.
Is it visible right now? I mean, like, or not?
No, so yeah,
no, okay,
we can't see it on your screen. If you're not seeing the panel at all, look for a little toolbar, probably on the upper right of your monitor. It might have an orange arrow. You might have to hit the orange arrow to expand it and then see the chat. Sometimes it collapses that way. Okay, I'm getting that people can see that. All right, great. Excellent. And you just feel free to type in there. I've resent the links. Some people said they didn't see the previous webinar link and the homepage link, so I've resent those. Hopefully everyone can view those. Okay, so we still have a few more questions that are being answered. Again, maybe slightly off topic, but I'll read through those. As now that everybody's got the chat window, they'll be able to send us more questions. One that came in earlier that Guillaume answered: I want the panel to update when I move the geometry of my nodes manually. And the response is, when you manually move mesh nodes, mind that you merge the nodes with the structure correction tools as shown in the presentation, then freeze the mesh and run the model generation.
Maybe I mean, if I understand the intention of the question correctly, is that the question is actually, is the contour or panel defined by nodes that are generated after the meshing? No. The characteristic points of the panel are not defined by nodes. So if there is a node in the corner, you move the node You move also the element, surface element generated in this location, but you will not move the or change the position of the panel itself. And this is I think the intention of the question. So no, you have to redefine the contour. You cannot move the node.
All right, and the response is yes, so that you're on the right page. So a follow-up question, so you loop through small moves and then structure fix?
Right.
Repeat
Again,
in a PDA program? We might be getting a little deep.
I mean, okay, let me maybe explain how I personally deal with the models that have incoherent, some issues with the geometry. It is basically what I try to demonstrate. I mean, first of all, I'm running model generation to determine what kind of issues I have in the model. If it is a lot of issues everywhere, then I start with this general correction to make sure that most of them disappear, and then I gradually move to the isolated locations and then decide what to do. Either it is like the correction, I mean, I freeze the meshes which are correct, and then I make the local corrections to the planes, or just move the nodes. So from using the big guns to the tiny corrections, like moving the two nodes and merging them. I don't know if this answers the question, but generally big changes first, followed by the tiny modifications.
Okay, great. And I think that was one of the things you had talked about last time too, that there's a lot of things here where there might be more than one way based on what you're trying to do, and a lot of things you have to kind of think about what is my end goal eventually, and then work my way back.
Absolutely.
People may find more than one way that's suitable for their specific project. All right, and we have a lot of thank yous coming in. Great presentation. It sounds like people are definitely learning quite a bit. I know I'm still kind of probably behind everybody on the first webinar, trying to catch up, but it really is amazing what can be done. Okay, so as the accolades for Artur come in, thank you for the presentation. Again, I think everyone's now got that chat panel, the links. As we've said before, there will be follow-up emails sent so that you have access to the presentation recording as well as the slides. There's also the forums, so the robot structural analysis forum. So if a question comes up later that you wish you had asked, please go to the forum, type that in, and the team would be glad to help you, guide you along. So we have some suggestions as well. Can we have a webinar about different solvers? So that might be something you guys can put on the list. Also, please, on the forums, you can leave your feedback there as well. I know that there is some scheduling already in place, so we may not be able to get to all of the requests right away, but we definitely do appreciate the feedback and try to cover the topics in order as they sort of make sense. And if they're graphically possible to go through a webinar presentation. So I know, Robot, you guys do have some limitations sometimes with the internet.
Yeah, there's one I can see about concerning seal structure. That's going to be the next one.
So the steel structure is next. Perfect. Happy face on that. Construction sequence phase analysis.
Yeah, it's also the topic for the one of the next webinars. I mean, perhaps.
Perfect.
Yeah.
You guys are you're right on schedule with what everyone's looking for.
I mean, definitely that's a good subject for a webinar. Yeah.
Perfect. Okay, so we've got a few minutes remaining as well. We'll leave it open for any new questions that come in. And again, don't panic. If you think of something later, please let us know on the forums.
Robot code. I mean, like, if the question is about the number, or I mean, the available design codes, then the check is you go to job preferences, and you select design codes, and you scroll down the list, and there is a button more. and if you press that, you can see the available list of codes for particular design, I mean steel or concrete. So this is the way you can check what codes are available. I hope that's the answer for the question.
Yeah, let's see. VB automation of a project I have created. Is that possible? So that might, as a follow-up from the code question.
Yeah, I will sort of advertise Rafał and Robot Forum. Anybody that is interested in the API to have a look at the Robot Forum. There's quite a nice and extensive section about different things that you can do with API, and Rafał is the best person to ask for help. Yeah.
Excellent. Yep, and Rafał just posted in the forum link, so that is available and for everyone to see. All right, great. So it looks like people are enjoying the webinar. Okay, so we'll maybe give it another minute or so. Oh, here comes one. Let's see. So I usually work with Robot 2013. When I open the same model in a newer version of Robot and work with it later with Robot 2013, so many concrete elements cannot be recognized by the 2013 version. Are there any recommendations for that?
Yeah, do not do this. There is no backward file compatibility for Robot. So you should not open the file, the new version, save it, and then go back to the older one. This is not supported operation. It shouldn't be done. If you have like two persons working on the same model, just make sure that they use the same version of Robot. Otherwise, you may run into issues with the models, with the files. So this is definitely something that I not recommend and even advise not to try.
All right, great, good to know. All right, wonderful. Okay, so any additional questions that you'd like to get into, Artur, or the rest of the group? Francois, Guillaume, Rafał, as we go through? If not, again, I'll invite you to that next webinar, on the concrete, which sounds like that's going to be a really popular one, and then our subsequent webinar series. And again, yep, as we said, the presentations will be available, the PowerPoint as well as the recording. There will be a follow-up email that comes in the survey, and it'll also have the links to let you know here's the presentation if you missed it or would like to review it, and here's the PowerPoint slides. All right, great. I'll turn it back to you then, Artur.
So if there are no further questions, I would like to thank you for attending this webinar, and I would like to invite you for the next ones. So, thank you for your time again.
All right, thank you. Have a great day, everyone.